Okay, guys, so like I said, 3.2, parallel lines and transversals. So the way that this works is we have corresponding angles. We have alternate interior angles. We have alternate exterior angles. We have consecutive interior angles, right? And then if you'll notice on the list, we have two more. We have vertical angles and we have linear pairs, many of which are present in this diagram here, okay? Now, notice every single one of these theorems here, every single one of these theorems, right, start with if two parallel lines are cut by a transversal. That is the very first part of every single one of these theorems. If two parallel lines are cut by a transversal. If two parallel lines are cut by a transversal. If two parallel lines are cut by a transversal. If two parallel lines are cut by a transversal. Okay, so this should communicate to you that if I have two parallel lines cut by a transversal, then what we're going to talk about these angles is going to be true. So the relationship or the relationship between the measurements, okay, is only true if the two lines that are being cut by my transversal are parallel. So my lines must be parallel for the following to be true. Okay, so I want you guys to make sure that you remember that, because if your lines that are cut by your transversal, if those lines are not parallel.
Excuse me, miss.
Yes.
Can you move up a little bit so I can write the objective? Thank you.
If those lines are not parallel, then the relationships that I'm about to say are not true, okay? So you must have your lines parallel in order for the following to be true. Now, what is it that I'm talking about, okay? Well, something beautiful happens when we have parallel lines being cut by a transversal. I wish I had patty paper, but I do not, okay? Something beautiful happens. We end up having these relationships where many of our angle pairs, many of the angle pairs end up being the same measurement, okay? AKA, what's another word for things having the same measurement in geometry? What's another word? Put it in the chat. Tell me you know that vocab word. What's another word for things having the same measurement in geometry? Gabriel's come through with it, but it's private, so I'm happy he did that privately. Okay, let's see if anyone else can get that. What is a word that means same measurement in geometry? Unless you're not wrong, Jayla.
They should know this one. Identical? What word means identical?
Mariel, good. Very good, Mariel. Jayla, not necessarily, hun. You're thinking too deep. Starts with a C. Nope, Destiny. Nope. Starts with a C. Sorry, spam phone call. Good, Joshua, and you just wrote that to everyone, man. Come on. Come on. But Joshua is not wrong, okay? It is the word congruent, okay? Congruent. So, in geometry, when we say congruent, we do mean same measurement, okay? Now, Andra said bisect, which is still, it's not fully incorrect because bisecting means you have two congruent parts, right? But the word bisect doesn't necessarily mean what the word congruent means, right? Congruent means the same measurement. So 3 out of 4 of these angle pairs end up being congruent. So let's take a look here. If for corresponding angles, okay, if 2 parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. Because we end up having the same, our transversal ends up cutting a parallel line and a parallel line. So we end up having the same measurements in every corner, okay? I wonder if there is a way. Yeah, I don't have any patty paper, guys, or I would totally show you what I was talking about. I have this paper really, really thin. Am I lucky like that? Nope. Oh, the joys of not being in the classroom. All right. Okay. So what does this mean? Okay. If 2 parallel lines are cut by a transversal, then pairs of corresponding angles are congruent. So what does that mean? That means that as we identified in our last diagram, right, corresponding angles. So in this case, we have angle 1 and angle 5, okay? Angle 1 and angle 5 are congruent, okay? Also, we have 3 other pairs of corresponding angles, right? So angle 1 is congruent to angle 5 because they are corresponding angle pair. Angle 2 is now congruent to its corresponding angle of angle 6. So angle 2 is congruent to angle 6. Okay. Angle 3 is congruent to its corresponding angle, angle 7. Okay. And lastly, angle 4 is congruent to its corresponding angle of angle 8. I know, a lot of arcs there, huh? But I'm showing that each pair is congruent to its pair. Okay. Now, those are my corresponding angle pairs. So each corner is congruent. Again, only if my lines are parallel. Okay. Now, then we have our alternate interior angles. Now, if 2 parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Oh, look, another congruent. So let's take a look at our alternate interior angles here, okay? That's going to be angle 3 and angle 6, and then angle 4 and angle 5, right? So now angle 4 is congruent to angle 5, and angle 3 is congruent to angle 6. So now these guys are congruent to each other, but that doesn't mean that these guys are no longer congruent to each other. They still are. There's a lot of congruency going on. Okay, and there's one more. Alternate exterior angles are also congruent. Okay, so that means now angle 1 and angle 8 are also congruent, and angle 2 and angle 7 are also congruent. Oh, wait, I'm so sorry. I forgot to write down these pairs. So from alternate interior angles, we have angle 3 is congruent to angle 6. And alternate interior angles, we have angle 4 is congruent to angle 5. And then my alternate exterior angles, angle 1 is going to be congruent to angle 8 because those are my alternate exterior angles. And angle 2 is congruent to angle 7. Okay. We got congruence galore. But remember I said 3 out of 4 of these are congruent, which leaves my consecutive interior angles. Okay. If 2 parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. Okay. The pairs of consecutive interior angles are supplementary, which means that then angle 3 and angle 5 are supplementary, and angle 4 and angle 6 are supplementary, which means that if I take angle 3 and I add it to angle 5, it will equal what? Oh, I wrote angle 3 twice, my bad. Okay, angle 3, the measure of angle 3 plus the measure of angle 5 will equal what? And also the measure of angle 4 plus the measure of angle 6 will equal what? What does it mean when 2 angles are supplementary? What do they equal when you add them together? And takers?
They equal 180.
They equal 180 degrees. Okay. So these are the relationships that happen for the measurements when we have 2 parallel lines cut by a transversal. So it is incredibly important that you remember how to identify corresponding angles, how to identify alternate interior angles, how to identify alternate exterior angles, and how to identify consecutive interior angles. Because when you have 2 lines, 2 parallel lines that are cut by a transversal, knowing that a pair of angles is corresponding angles tells you that they are congruent. Recognizing that a pair of angles are alternate interior angles tells you that they're congruent, aka their measurement is the same. Knowing or recognizing that a pair of angles are alternate exterior angles tells you that they are congruent. Recognizing that angles are consecutive interior angles tells you that they are supplementary. So instead of setting them equal to each other, you're going to add them and set it equal to 180 degrees. Okay. Now in each quad, each intersection that happens, we have these 2 angle pairs that also get created. Okay. So if you remember our vertical angles, okay, every pair of vertical angles are congruent to each other. Every pair of vertical angles are congruent to each other. So in this intersection up here, in this quad, I have 2 pairs of vertical angles. Remember, vertical angles are directly across each other, right? So in this situation, I have angle 1 and angle 4. So that means that angle 1 is congruent to angle 4. I also have angle 2 and angle 3. So that means angle 2 is congruent to angle 3. Okay. That's for that intersection. I also have a similar situation happening in this bottom intersection where I have 2 pairs of vertical angles. Angle 5 is going to be congruent to angle 8. And angle 6 is going to be congruent to angle 7. Oops. Okay. In addition, every intersection has multiple pairs of linear pairs. Okay. So remember that every linear pair is supplementary, which means that their sum equals 180 degrees. Now, we have many linear pairs in my diagram here, okay? So first, let's take a look here. Remember, linear pairs are two angles that create a line, right? So let's start with this. This line right here, my first parallel line. I have angle 2 and angle 1. They make this line, which is a linear, which makes them a linear pair. So that means that angle 2 or angle 1 plus angle 2 will equal 180 degrees. It also means that down here, angle 3 and angle 4 are a linear pair. So angle 3 plus angle 4 is equal to 180 degrees. But that's not the only line. Line P here is not the only line with these angles. We also have line T. So if I take a look at this pair right there, they also create a line with these two angles right here. So that means that angle 1 and angle 3 are also a linear pair. So angle 1 and angle 3 add to equal 180. And similarly on the other side of line T, angle 2 and angle 4. So that means angle 2 plus angle 4 and equals 180. Okay. This goes hand in hand with our vertical angles. Because look at this. Angle 1 plus angle 2, angle 1 plus angle 3. And we said that angle 2 and angle 3 are equal to each other here, right? So by vertical angles, angle 2 and angle 3 are equal to each other. So we're really adding the same measurement to angle 1 here. And then similarly over here with angle 1 and angle 4. Okay, because I have angle 2 plus angle 4, and then I have angle 3 plus angle 4. Or you can look at it the other way, right? But either way, angle 1 is equal to angle 4, or angle 2 is equal to angle 3, right? So again, I'm adding the same measurement to angle 4 to get 180. So they're literally connected together. These same reasons help us with these congruencies, okay? But we're not done. I want you guys to take a moment and I want you to list the linear pairs from this quad. I want you to list the linear pairs from this quad. So you have your linear pairs being created by line Q and line T. Okay, I'm going to give you guys a minute to list those right there. All right. So let's see here. Jayla, were you able to list a pair? Jose, I'm also going to be calling on you. Jayla, are you there? Going once. Going twice. Okay. All right, Jose, can you give me a pair? Jose? Give me a pair of linear, give me a linear pair from the bottom quad. Okay, 7 and 8. Yes, angle 7 and angle 8 are a linear pair. That means angle 7 plus angle 8 will equal 180 degrees. All right, Andres coming through with another one, angle 5 and angle 6. Yes, on the other side of line Q. So angle 5 plus angle 6. Okay, let's hear from other people. Gabriel, thank you for yours as well. Andres, okay, 5. We're looking for linear pairs, Mr. Leon. The linear pairs can only come from the same quad. Okay, same quad. So I have 6. Oh, someone said, who said that? Andres. Morena also said angle 6 and angle 8. Yes, right along this line here, right? Angle 6 and angle 8. So angle 6 plus angle 8 will also be a linear pair. Very good. Angle 5 and angle 7. Yes, Adamari. And that's our last one here, right? Okay, very good. And again, we can see that there are some consistencies here. So if I look at 7 and 8 and 6 and 8, right, I see that angle 7 and angle 6 are congruent to each other. So really, I'm adding the same measurement to angle 8. Okay, same thing could be said for angle 5 here. And the same thing could be said for angle 6 here with 5 and 8. Okay, and 6 and 7. So we're really just adding a bunch of congruent angles. And we can interchange them, right? We can substitute one for the other because they're congruent. All right, let's actually put this into action. So really quickly, let's review, okay? Because we spent a lot of time on that linear pair. Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Consecutive interior angles are supplementary. Vertical angles are congruent. Linear pairs are supplementary. Okay, so let's take a look here. We have our first example here in our I do. Let me zoom in. Okay. Oops, I'm sorry. Too much zoom. Too much zoom. Zoom, zoom, zoom. Okay. So here we go. We have 2 parallel lines. I see my symbols for parallel lines. I have my little arrows, 1 and 1. That tells me these lines are parallel, which means I have a bunch of congruent and supplementary angles here. Okay. I've been given this angle here, 110 degrees. And I'm being asked to find the measure of angle 1 and 2 and state which theorem you used. Okay, so the goal is to find a relationship or an angle pair with this 110 degrees and these angles. And I can't do it with 3 angles at a time. I have to do 2 angles at a time. Okay, that's why they're called angle pairs, right? So let's say I ignore angle 2 real quick. Let's say I ignore that angle real quick. Okay, let's find the relationship or the angle pair between 110 degrees and angle 1. Okay, so I can see that this is a measurement because it has the degrees and the 1 doesn't, so that's a name, right? What's the relation or the angle pair of angle 1 and this angle that's 110 degrees? Are they corresponding, alternate interior, alternate exterior, consecutive interior? Which one are they? So I take a look. I see that they're both in between my 2 parallel lines, right? They're both in between, so they're in interior. They're a pair of interior angles. They're from different quads or intersections. Okay, so they're not going to be like vertical angles or linear pairs. Okay, so interior, right? So that means they can either be alternate interior or consecutive interior. Well, they're on alternate sides of the transversal. One is on this side, one is on the other side. So these must be alternate interior angles. Okay, again, alternate, they're on opposite sides of the transversal. Interior, they're between my 2 parallel lines, and they're from different intersections. One's from the top intersection, one's from the bottom intersection. So alternate interior angles theorem tells me that these 2 are congruent, which means that they have the same measurement. So if this angle is 110 degrees, then the measure of angle 1 is also 110 degrees. Mr. L, would you like to contribute something?
No, I was actually asking somebody what is angle 1 and 2. I don't know if that's jumping ahead or not.
So so for angle 2, we can look at it multiple ways. We can now try to find a relationship between angle 1 and angle 2, or see what kind of angle pair they are, which they do have an angle pair. Or we can look at the 110 degrees again and see if that angle and that angle have an angle pair relationship. Okay. Do those 2 angles have an angle pair relationship? The 110 degrees and angle 2? Are they corresponding angles? Are they alternate interior angles? Are they alternate exterior angles? Are they consecutive interior angles? Right, we're looking at angle 110 degrees and 2.
They are definitely one of those.
Yes, they are. Okay. So if I take a look, one is inside my parallel lines, one is outside. So that really automatically excludes anything that's like exterior and interior. If I take a look at the intersection, I should see 110 degrees is on the bottom right corner. Angle 2 is on the bottom right corner.
They're in the same position.
Yes, they are,
Wow.
which makes them corresponding angles. And if my lines are parallel, then my corresponding angles are congruent. So this is going to be my corresponding angles theorem, which means that the measure of angle 2 is also 110 degrees. Okay. Or I could have noticed that angle 1 and angle 2 have a nice little relationship. I could have seen that angle 1 and angle 2 here are right across from each other, same intersection, making them vertical angles. So by the vertical angles theorem, I could have even said that the measure of angle 2 is 110 degrees because the measure of angle 1 was 110 degrees. So either one of these would have worked for the measure of angle 2. So you will have to kind of do a process of elimination if it doesn't automatically jump out at you. Okay, so let's take a look at this one here, the we do. Let's take a look at the we do. We're given our transversal here, my two parallel lines cut by my transversal. I'm given this angle here as 63 degrees. And I need to find the measure of angle 2 and the measure of angle 1. Okay. Do you see any relationships between the angles here? Any pairs that you can identify?
Consecutive interior angles.
Which two are consecutive interior angles?
Angle, the angle that is 63 degrees and angle 2.
Okay, so the angle that is 63 degrees and angle 2 are consecutive interior angles. Yes. Okay, we can see they're interior because they're between the parallel lines, right? They're on the same side of the transversal. They're from one, each of them is from one of the intersections. So our consecutive interior angles theorem makes these guys supplementary, right? Which means I'm not going to just set them equal to each other. I'm going to add them and set it equal to 180 because they're supplementary. So angle 2 plus 63 degrees is equal to 180 degrees. Okay, I use some algebra here to solve, and I just do 180. And I would subtract the 63 degrees over, right? And 180 minus 63 is 117. So that means the measure of angle 2 is equal to 117 degrees. Okay, that's our consecutive interior angles theorem. So this guy here is 117 degrees. Okay, now, is there a relationship that you can find? Is there an angle pair between 63 degrees and angle 1 here? Is there an angle pair between 63 degrees and angle 1? Notice that they're both, again, in the same position in their intersections there. So these are corresponding angles.
Which makes them congruent.
Which makes them congruent, absolutely. So the corresponding angles theorem tells me that angle 1 is going to be equal to this angle, so that the measure of angle 1 here is going to be 63 degrees. Just like that. Okay. All right. Any questions before I give you guys some time to attempt a you-do? Okay, we have a you-do here for you that you're gonna try to complete on independently. Okay. So we have, I'll move this down, don't worry. Okay, there we go. Any questions? Waiting for questions here. You can either unmute or write it in the chat. Okay, so I'm going to give you guys 3 minutes to do the you-do. You're given this angle here at 95 degrees. You are asked to find the measure of angle 1 and the measure of angle 2. Okay, 3 minutes on the clock. Okay, so that was our 3 minutes. All right, so who can tell me the measurement of angle 1? I want to hear from people that don't normally participate in class. And I thank all of you that do participate in class. Okay. But I want to know who can tell me. Oh, yeah, please. Who can tell me the measurement of angle 1?
Angle 1 is 95 degrees.
Angle 1 is 95 degrees. Okay. Why?
Because it's a vertical angle.
Yeah, very good. Okay, so this would be our vertical angles theorem, which would make the measure of angle 1 equal to 95 degrees. And it's a vertical angles with that angle right there, right? Right across from each other. Okay. All right. So what about the measure of angle 2? Measure of angle 2 here. What's my measure of angle 2? I think I'm going to pick someone. Kebra. What did you get for the measure of angle 2, my dear? Kebra? You there?
Hi.
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 What did you get for the measure of angle 2?
I'm not unmuted. I mean, I'm muted. I mean, I'm not unmuted. I don't know what I'm saying. I'm confused.
Okay.
Okay.
So what do you know?
What do I what?
What do you notice? What angle pair do you notice between angle 2 and the angle that you're given, 95 degrees?
Mm-hmm.
What's the angle pair between them?
What's the what?
What's the angle pair? Is it
What
corresponding?
kind of pair are they?
Are they corresponding angles? Are they alternate interior angles? Are they alternate exterior angles? Are they consecutive interior angles? Are they
They're
vertical angles? Are they linear pairs?
Okay. Are they corresponding?
Okay, so they're corresponding angles.
Okay.
Okay, so does that mean that they're congruent? Or does that mean that they're supplementary?
Congruent?
Okay, so if angle 2 is congruent to this angle, then what's the measure of angle 2?
Congruent means the same.
Question. It's 95 degrees?
Why is it 95 degrees?
Is it 95 degrees?
I'm asking you.
It's 90. I'm gonna go with 95.
Why?
Because it's the only one on thing. I'm not crying. Because
Yeah, go ahead.
because it's like in the middle of the the two things, two angles.
Kebra, you just told me they're corresponding angles, right?
Uh-huh.
And then you told me that corresponding angles are congruent, right?
Huh?
What does the word congruent mean?
Um, um, hold on 1 second, please. It means it's the same
Okay, so why is the measure of angle 2 95 degrees?
because it's the same.
Why are they the same?
It's like you see how there's like 2 is in the same place as the 95 degrees is, so it's like the same angle.
Right, which makes them corresponding angles, right?
Yes.
Okay. Good.
Are we done here?
Yeah, I would really appreciate it if you weren't as distracted next time.
Sorry.
All right, thank you. Okay, so we should have gotten that both of these were 95 degrees, okay? You could have also said what? If you looked for an angle pair between angle 1 and angle 2, what's the angle pair between angle 1 and angle 2? Any takers? What's the angle pair between angle 1 and angle 2?
85.
85. No, I'm not asking you for the measurement. Not asking you for the measurement. I'm asking you for the angle pair. Guys, every time I say angle pair, I am referring to the name of the pair.
Miss Kay?
Alternate exterior angles.
Yes, thank
I just
you.
wanted to point out that's the second time I've heard 85 degrees.
I have two, and it's weird. Why would it be 85 degrees?
I can see, you know, they're totally lost 94 or something, or 96 or whatever, but I don't know where that's coming from exactly.
I don't know where you guys are getting the 85 degrees from. Can someone explain? Maya? Can you give me an idea as to where the 85 came from? Or Gabriel? Or who was that just spoke? I think it was Gabriel. Or was it Michael? You guys gotta let me know where these are coming from so I can help you. Oh, linear pair. That's right. Yeah, 180 minus 95 is 85. You're absolutely right. Yeah, no, we don't have any linear pairs here. No linear pairs. We have vertical angles that are across from each other, right? And then someone said, who was it that just said? Andres Moreno said that angle 1 and angle 2 here. Okay, these two angles, the angle pair would be alternate exterior angles, which are still congruent. Alternate exterior angles are still congruent. All right, where'd it go? Right here. They're still congruent. So even whichever angle relationship you had gone with, you would have still gotten that the measure of angle 2 is 95 degrees. You would have still gotten that the measure of angle 2 is 95 degrees. Okay. We actually didn't have any linear pair. Thank you for that clarification, Michael. All right, flip it over. We got some more examples. We got some more examples. All right. Now we bring in some algebra into the mix. Okay, now we're bringing in some algebra into the mix. So let's take a look here. Okay, this guy here. I am trying to solve the algebraic equations, okay, by using the angle pairs and whether or not they're congruent or supplementary. So it says you can also use theorems to set up and solve algebraic equations and measures of angles. Okay, so I have my two lines here. They are parallel, which means I have angle pairs that are either congruent or supplementary. Literally, there's only two, right, setups here. You either set things equal to each other or you're gonna add them and set it equal to 180. So if they're either congruent, meaning equal, or they are supplementary, meaning add and set equal to 180. The key is to figure out which angle pair you have so you can know which relationship to have, right? So angle pairs, again, angle pairs are corresponding, alternate interior, alternate exterior, consecutive interior, vertical, and linear, okay? Angle relationships, congruent or supplementary in this situation. So taking a look at my two angles here, x plus 12 degrees. Oops, sorry, I moved over the paper. X plus 12 degrees in this corner, 110 degrees in this corner. What is the angle pair here? Write it in the chat. Show me you know. Show me your understanding, or you're trying. Even if it's wrong, show me you're trying. What is the angle pair? Thank you, Gabriel. Thank you, Andres Moreno. Thank you, Adamari. So the rest of you are borderline, actually not borderline, the rest of you are literally going to lose your participation points because you're not participating. Okay. Thank you to the three of you that responded. You are absolutely correct. These are alternate exterior angles. Okay, alternate exterior angles, which means they are congruent. Okay, congruent means they are equal. So if these two angles are alternate exterior angles, I have my parallel lines here. Alternate exterior angles are congruent due to our theorem on the front page, okay? So that means these two angles are congruent to each other. So that means x plus 12 degrees is equal to 110 degrees. There's my equation. They're congruent, therefore they're equal. So I literally take one angle and set it equal to the other angle, which means that x plus 12 is equal to 110. And then I solve. Subtract 12 on both sides, and I will get x is equal to 98. Done. Done. That's it. My two angles, alternate exterior, which tells me they're congruent, which tells me they're equal. So I set the two angles equal to each other. Okay? Let's take a look at the we do. Let's take a look at the we
Go back
do
up
here.
a little bit. Sorry.
Oh, sure. You're still writing it down?
Yeah.
Okay. Okay, so we're solving for x here. This is 4x degrees. This is 52 degrees. And this is angle 6. Notice there's no degrees. So it's just angle 6. That's going to help us. Okay.
Okay,
So,
I finished. Thank you.
So let's take a look here. I have 4x degrees and I have 52 degrees. If I take a look at these two, they're both on the exterior. Okay, they're both on the exterior, but they're also on the same side of the transversal. which means they can't be alternate exterior. Okay. Now I don't have a same side exterior pair of angles, so I have to try to figure out another way. Maybe that's where the 6 comes in here, angle 6, right? So if I try to ignore the 4x right now, ignore that, I should be able to see that 52 degrees is corresponding with angle 6. Okay, so corresponding angles are congruent, which means they are equal. So if 52 degrees and the angle 6 are congruent, aka equal, then that tells me that the measure of angle 6 is 52 degrees. Okay. So this is going to help me because now what is the angle pair between 4x and angle 6?
They're supplementary
Why are they supplementary?
because they are. What is it? Parallel lines.
Almost. You see how they create a straight line here?
That's part of the relationship, but not quite.
Right? You see how they create a straight line? These two angles, same intersection, right? Creating a straight line. These are a linear pair. So 4x degrees and angle 6 are a linear pair, which means they are supplementary. That means that 4x plus the measure of angle 6 will equal 180 degrees. Well, I just found the measure of angle 6, didn't I? I found the measure of angle 6 was 52 degrees. So this would be 4x plus 52 is equal to 180. Now I solve. Subtract 52 on both sides. That gives me 4x is equal to 180 minus 52, which is 128. Divide by 4 on both sides, and I will get x is equal to 32. Okay. I'm open for questions here. Staying silent is not beneficial for you. I just want to throw that out there. Staying silent is not beneficial for you.
Wait, wait.
Yes.
For the angle, you substituted 6 for 5.2, and then that's how. And
Not
from
2,
like
52. Because over here, because of corresponding angles, we found that angle 6 was 52 degrees. Yes?
yeah.
You caught that part?
Mm-hmm.
Okay, so over here, I know that the measure of angle 6 is 52 degrees because I found that here.
Got it.
Yeah. All right, so we have 6 minutes left to class. I am asking that you do number 1 and you do number 3. Okay, you do number 1, you are solving for x. You do number 3, you are solving for angles 2, 3, 4, 5, 6, 7, and 8. Okay, When you submit your notes, I want to see these two done. Also, you have an exit slip for today. But again, your exit slip is not due until tomorrow night because I want you to have a chance to do your homework that's on big ideas before you do your exit slip so you can have some nice practice with feedback. But here's your exit slip. Okay, you're given a figure and you're given 2 problems to use from the figure. The answers from number 1 do not relate to the answers from number 2. All right, so you have a few things as with every end of class. You have your exit slip, upload your completed notes, and your homework on big ideas. Okay. All right. So I will be on here